Note, let's see what the question is asking after that. The first part is definitely the aircraft being starboard of the track. So the aircraft is starboard of the track. But the question doesn't stop there. It's asking you to find out whether the aircraft is closer to A or to NDB B. Now, how will you find that? Not a very navigation application is kind of required here. It's your basic mathematics, and if you can identify a triangle, and that should be more than enough. Let me kind of cast a line here all the way straight. Now, say for example, the line is say 100 kilometers long, and I'm kind of marking a point that is 50 kilometers, which is right the midway, right? Now let me draw a perpendicular line passing through this midpoint. The blue line kind of bisects the black line, right? So that is the bisection point, which is right here. Now think about any point on this particular blue line, anywhere on the blue line, which is right here. I've just imagined a point there. Let's join these points to form a triangle. All right. What do you understand about this triangle? For any given point on this line of bisection, these two sides should be equal. Doesn't matter which point you consider. If I consider another point which is right here, and if I kind of join these 2 points to form one of the sides of the triangle, we can again see that these 2 sides should be equal. So basically it's an isosceles triangle. All right. Now this understanding will kind of help you to also understand that. Let me just get rid of the yellow line here, just to make it much more simpler, right? It will also help you to understand that since these 2 sides are equal, their opposite angles also should be equal. Now, which means that, say for example, if I take this angle to be 120 degrees, the awareness that the sum of the triangle is 180 degrees, the rest of the angles should add up to form 60 degrees, 180 minus 120. Therefore, this is going to be 30 degrees each. So if in a triangle, if 2 angles are kind of equal, and the third point, the third vertex of triangle is kind of on the bisection of the opposite side. That's exactly what you've seen here. Now, what if I kind of shift this particular point from here, and I kind of keep this point somewhere here? Let's kind of join the triangle and see. Perfect. Now look at what happened to this 30-30 angle. The angle over here kind of went less than 30, and the angle over here kind of went more than 30. Right? Now let's imagine what would have happened if I had shifted this point somewhere to the left, which is right here. And let's now join join the lines to form the triangle. Right? This might seem a bit silly and different, but this is a way by which you can find out whether it's closer to A or B, and you must have got a hint by now itself. Look at what happened when the point got shifted to the left of the actual point. The angle over here went more than 30, and the angle over here went less than 30. So by looking at the 2 different angles, you can kind of figure out whether the third vertex is closer to one of the points or the other one, right? With the same understanding, let's transfer it to this particular figure here. What I'm trying to tell you is that if I can find out these 2 angles, at least one of them, not necessarily 2, I can very well predict or kind of tell whether the aircraft is closer to A, NDB-A, or B, the NDB-B. All right. Let's try to find out the angle at NDB-A. It's pretty clear. 50 degree is the planned track, which is right here. This is a planned track. The actual track flown by the aircraft, which is the track made good, is 60 degrees. So what we're looking at here is a track error of 10 degrees to the right. Perfectly, that's 10 degrees. Not really bothered about track error here, but the angle is 10 degrees. All right. Now, if the aircraft is at the intersection of this particular track here, then this angle also should be 10 degrees. If that angle is more than 10 degrees, which means the angle has to be wide, and for that reason the aircraft has to be somewhere here, right, for this angle being 10 degrees. So let's see what the angles are again. So let's find out what is this angle. Because if we can find this angle, then it's very easy to find third angle. So that angle is basically the angle between 180 degree and 330 degree. Alright, that is nothing but 150 degrees. And therefore the third side, the total should be 180, one being 10, which is right here, and the other being 150. The third side has to be 20 degrees. Now what does this tell us? This tells us that this particular point or the aircraft is not on the bisection line of the planned track. Did you get what I'm trying to say? Alright, so what does it tell you? The angle made at Bravo is 20 degrees, which is more than the angle made at Alpha, and this means that the aircraft is definitely closer to Bravo than Alpha. It is much closer to Bravo than with Alpha. So let's write that out here. The aircraft is to starboard of the track and nearer B, the NDB B. Let's look at the options here. Starboard of the track and nearer B, it's delta being the answer. Alright, so delta is the answer for this question. I hope you understood. Two different things. When you're trying to find out whether the aircraft is port or starboard of the track, and number two, you're trying to find out whether it is closer or away from the from either of the NDBs. Two of them done two different ways. Now let's kind of see the same question from a general perspective. General view as in not many values in place. We're just kind of drawing a similar diagram but not talking about any values as such. Alright, so let's draw the track again, that is from NDB A towards NDB B here, and let me keep the aircraft to starboard of the track as in this particular question that we have seen. So let me place the aircraft on any random heading. As well as it's moving out of A, I'm kind of happy. So the heading, I'm just placing the heading over here. Doesn't really matter, as I told you what the value is. And now let's complete the triangle. The aircraft now flew a track made good from A. This is the planned track, and this is the track made good. Oops. If you have questions, do drop in the chat. I will attend to it. And the aircraft is now supposed to fly a track of this to kind of track towards B. You have seen 1 in 60 questions, so I know you that. You know it, right? Now, let me make a better aircraft for you just to get what I want to explain ready. Alright? Yes, so let me put the aircraft here. This is the aircraft. Alright, now let me put the aircraft to the port of track. So this is a starboard of track. Let me put it to the port of the track. The aircraft drifted off to the port. So track made is good is kind of to the port. So let the aircraft be somewhere here, and this is a track made good now flown by the aircraft. Two different scenarios. I'm just trying to give you a general perspective of the same question, so that the same situation in fact. So in the event any other kind of scenario is given, you know how to relate it. And now the aircraft is supposed to track like this towards B. Let me place the aircraft on somewhat the same heading just to make the depiction easier. Now we're looking at the RBI indications here, for which, as I've explained before, try to draw a circle around the aircraft and make it in place. ADF needle simply shows you where the NDB is, and on that note, let's kind of draw both the ADF needles, one tuned into NDB A and the other to B. Over here, the one tuned to NDB A will be like this, and the other towards NDB B, right? Now, if I ask you to give some random values to this, how would the values be? Now, what you have to understand is, and as you know, the RBI, the head of the RBI is 0, or the kind of a nose of the aircraft, not the heading, right? So let me place that here. The head of the RBI, which is in line with the nose of the aircraft, is always 0. So on that note, if you look at it, you can I can probably mark this as, say, 20 degrees, and this may be like 160 degrees, right? Because if nose is 0, then tail is going to be 180. Let me mark it in both the scenarios here. What about the case of the other aircraft to the right of the track? So this is going to be somewhere around 330 degrees. Like rough values, and this is going to be somewhere around 210 degrees. All right, let me take one of the RBI indications here and kind of shade the portion which has the ADF needle in it. Similarly, if I kind of shade the portion over here, it is the right of the aircraft, right, where you have the ADF needles. Perfect. So what do you see here is when the aircraft is to the right of the track, then the ADF is kind of indicating values which are like anywhere between 180 and 360. So 180 is right here, 360 or 0 degrees is right here. If the value is anywhere between 180 degree and 360 degree, excluding 180 and 360 both, then the aircraft is to the right of the track. So think about it. When you have a particular track towards this side and the aircraft is on the right of the track, then both the NDBs are towards the left, right? And as far as the aircraft is concerned, the left side is going to be more or less a relative bearings between 180 and 360, okay? Because it is with respect to nose of the aircraft, right? Similarly, if you look at the RBI reading here on the aircraft that is to the port of the track, you can see both the values, one is 160 and the other is 20 degrees, are between 0 degrees and 180 degrees, again excluding both those. If I kind of put the aircraft exactly on track, which means let the aircraft be here, then you can see what happens. You will have an ADF indication. Let's draw the circle in place here. Let's squeeze the circle. Yes, perfect. The ADF tuned to A will indicate 180 and towards B will indicate 360. Now I have not assumed any drift here. If there is a drift, it's plus or minus starboard and port drift from 360 and 180. Basically, it indicates values between 360 and 180, right? So this is how it works. So I wouldn't necessarily ask you to probably understand these questions in this way. So in this question, if you look at the question straight, you can see the values 180 degree and the other value being 330 degrees. Now this will tell that 330 has to be to the left of the aircraft, and for that reason the aircraft has to be to the right of the track. All right. Now, as I told you, I wouldn't probably recommend you to understand this using this general view. General view is kind of an easy technique to kind of find out the answer from the question. I would probably ask you to do exactly in the way we explained the first part of it, because that is the more conceptual way of understanding the question. All right. Yes, if you have, so basically the aircraft is in this particular question is on the right side of the track, closer to B, and I hope you understood how we found out whether it is closer to A or B. On that note, let's kind of very quickly jump into another question. This is a picture-based question over here, question number 7, right? Read the question with me. An aircraft is tracking away from an NDB on a track of 23 degrees true. If the drift is 8 degrees port and variation is 10 degrees west, which of the RMIs illustrated below shows the correct indication? So you can see there are 4 different RBI and RMI indications given here in the question, and you are asked to find out which of these indications is correct with respect to the question that is given. Read through the question once again, take a pause. I'll give you 5 minutes, just go through it. Very kind of a concept-based question. If you can do this, probably your concepts of RMI and RBI is kind of clear, right? Try to draw a diagram and see whether you can find this particular indication on your diagram. I'll see you after that.